if you're going to heat electricity, it's an efficient way to use electricity. And there are a lot of houses in the village that just have electric furnaces with forced air distribution or electric baseboards. So the ground source heat pump uses less electricity than those systems do, so it's an efficient use of electricity, but it is still a way of heating with electricity. If it's replacing a baseboard heated house, it provides the benefits of a centrally ducted forced air system, which gives heat to all parts of the house and air movement to all parts of the house. So if a building needs more air distribution and has problems with stagnant areas in a baseboard heated room, it's the benefit that comes from forced air wherever the heat is coming from. It also means that if it's replacing a baseboard electric heated house, it can be scheduled on and off with night setback, which otherwise is more difficult to do with individual unit baseboards, going around turning each one down or putting a programmable thermostat on each one. So that's just the benefits of bringing a baseboard heated house into the same realm as the other forced air heated systems. Its particular benefit is it's an energy efficient way of providing air conditioning, because you can reject heat to the cool ground temperatures rather than the warm outside air in the summertime. So it's definitely advantageous if you've got a big air conditioning load. It puts all of the mechanical equipment for the house inside the house. So if otherwise you had an air conditioning system that has an outside condensing unit, noisy, subject to hail and weather damage or vandalism, you don't have that anymore. The ground is the condensing unit in air conditioning mode. It provides domestic hot water heating as a supplementary benefit, and that domestic water heating is free in cooling mode, because otherwise that heat would be rejected to the ground. So why not use that heat for something useful, like heating your shower water? And it's also important to note that the domestic hot water heating requirement is part of the heating capacity. So if you just size the heat pump to the line on your space heating requirement, you are going to be taking away some of that heating capacity if you want to heat domestic hot water at the same time. So it would be better to have some storage capacity for domestic hot water where you could divert the heating capacity of the heat pump. So it would be heating domestic hot water when it didn't have 100% call for space heating at the same time. So just saying that the domestic hot water is a competing call for the overall heating capacity of the heat pump. However, when it's in cooling mode, it's essentially free. And many of the new high efficiency heat pumps come with variable speed DC motors in them, which are much more energy efficient than the regular motors that are used in furnace fans conventionally. So it's sort of a side benefit that you use less electricity to blow that air around. But fan electricity is a significant portion of the operating energy in a house with forced air heating. And so whatever kind of furnace you've got, if you're buying a new one, it should be an ECM motor in it that runs on variable speed according to the demand. And heat pumps are a great match for radiant floor heating because it's low temperature. And heat pumps are good at heating water or air a little bit. So radiant floor heating systems are good because they can use the coolest temperature water. If you've got baseboard rads, they need hot water, like 60 or 70 degree water at least to get useful heat out of them. The radiant floor can work with 28, 30 degree water, and that's the range that the heat pump loves to operate, and that's when it's really efficient. It's expensive. First cost, capital cost is expensive, and if you're to treat it as an economic investment like others, you want to be sure that it provides as good an economic return as another investment in energy efficiency would. So say it's $20,000 to retrofit your house from your present system to ground source heat pump, and your current energy bill is $2,000 a year. You want to be very confident in what you can expect as an energy saving. It's not going to be, your energy use is not going to be 3 or 4 times less than what it is now, because that's the thermodynamic maximum it could possibly be were the whole system to operate at the rated peak COP of the equipment of 3.5 or 4. Oh, COP, the coefficient of performance, that's how much you get out for what you put in. It goes out over the goes in. So I get 3 kilowatt hours of heat out of my heat pump for the 1 kilowatt hour I put into the compressor. Oops, but what about the kilowatt hour I have to put into the well pump? Better add that in. So now that equation gets changed because I'm starting to put more in the bottom of the equation. So just when you're talking energy efficiency, you have to count all the marbles that are on the board. And remember that rating conditions are at specific rating conditions, and your operating conditions may differ. And they're not likely to be as good as the lab. Seasonal efficiency of COP of 2, okay, so let's, for the sake of argument, say it's 2. And that means, okay, maybe I'm going to save $1,000 of my $2,000 a year heating bill, and I'll pay $20,000 to get that. So that's my simple return. To look at it coldly, is there a better way I can spend my first $20,000 of discretionary expenditure on my house? That also would reduce the energy bills by $1,000 a year or more. And that's a house-by-house decision, but you can certainly get an order of the magnitude feel for that by knowing what do you spend every year in heating energy. And so maybe at the end of our survey exercise, people will have a better idea about that. And then what's one of these systems cost to put in? And let's make sure we include all the costs in it. So one of the misses many people have been unpleasantly surprised to find is that after the ground heat exchange system has been installed, there's still a wee bit of landscaping to do to repair the gardens and yard. And if that's not included in the installed cost, then somebody else, a landscape contractor, is going to have to come and repair the gardens and the yard. That piping has to get into the house somehow, so there'll be trenches that are excavated between out there and somewhere in your house. And then there's the penetration into the house that has to be coordinated. Where is that piping going to come in? And maybe there's some disruption between where the piping comes in through the foundation and where the heat pump is ultimately located. So there may be some architectural renovation costs to restore that. So make sure those are costed. And then let's not forget that nothing operates for free. This is mechanical, electrical equipment, and it needs periodic maintenance. And everybody should carry a budget amount for an annual maintenance amount. And these costs are not well established yet now, but we know they're not zero. So you should consider that there's going to have to be some sort of regular or irregular maintenance. This is vapor compression equipment that's got compressors and refrigeration controls in it, and you could expect reliability and longevity to be similar to air conditioning equipment. Is probably the closest piece of equipment in the house. It may be better, but it may be worse. It's newer technology. The new high efficiency models are also using different refrigerants. Because it's more complex equipment, obviously when something fails and needs service, it's going to cost more to repair. A refrigeration mechanic costs more on an hourly basis than oil burner service does, or an electrician does who's got to replace a dead electric heater. So how long is a compressor going to last? Okay, maybe it'll last 10 years. And then what's it going to cost to replace? How about, I don't know, $3,000? So better amortize that on a yearly basis. So I've got $300 a year I better have in my savings account for an eventual replacement of an expensive component. And maybe it'll last 20 years, but don't know. Equipment hasn't been in, at least the new generation equipment hasn't been in for 20 years. But regular commercial quality air conditioning compressors have a predicted lifetime of 10 to 15 years. We hope with lower condensing temperatures and pressures in this equipment it may last longer, but we're dealing with new refrigerants and new lubricating oils here that we don't have a lot of experience with. The industry spokesman will definitely say that it's better than propane furnaces, and have some standard charts saying if you're spending $3,000 a year on propane, you will only spend $850 a year with electricity. And I'm not prepared to discuss that until I saw a real example. But no, the sales are based on promised energy savings. It's just there has never been a case where the promised energy savings are realized. I worked with one resident of the village who was determined to replace his electric heating with the best possible ground source heat pump system he could put in. And he got 3 quotes. We went over the quotes. We chose who we thought was the best supplier. We tried to work with that supplier to provide what was really needed and to clarify what was not included in his quote. It was an open loop system where the homeowner drilled a new well to feed the heat pump as well as a new water system to the house, put in a new submersible, top of the line, variable speed well pump, and then used the old well for the recharge well. So it did the environmentally right thing. And after 2 winters of operation, he said his electricity bills are about the same what they were before when he was heating with electricity. But he's heating much more of the house because he used to turn off rooms with the baseboards, and now the blower is on when there's a call for heat and on 30% of the time when there's not a call for heat to keep air distribution. So he says, for sure the house is more comfortable than it was before. But I'm not spending less on electricity. And maybe I'm off 15% in my comparisons by the inaccuracy of my rough and ready comparison of my electricity bills, but by no means am I using 33% of what I was spending before. And yes, there's different heating degree days in the different winters, but last winter was a mild winter, so why wasn't my electricity costs even less than a third of what it was. Because, well, I've got a submersible well pump, a 1 horsepower or 1.5 horsepower well pump there that's oversized, has to be throttled down to reduce the flow rate through the heat pump to what it needs. And that pump comes on most of the time and I need heating. So now I'm running a 1 horsepower well pump. That's not included in the advertised COP of 4 by the heat pump manufacturer. The ductwork wasn't well installed, because when you're changing from baseboard to forced air, you've got a whole forced air system to put in too. It's not just a box in the mechanical room. So all of the design issues about what is good design for sheet metal come into play, and that's where you really, really have to have a good sheet metal worker there that doesn't necessarily do just the way they've done it for the last 20 years. And it's important to note that the vulnerability of the heat pump system is its reliance on the electrical distribution system. So we get ice storms in the winter, so it's likely to fail at the time when you need it most. And with demands of 40 and 50 amps for these systems, that's beyond the scope of a regular small household generator. You won't run these systems off a battery pack from your solar PV array on your roof or from a small Home Depot generator, which you can run a furnace on. So maybe a furnace wants a couple amps for the blower motor or your boiler for the circulating pumps. A heat pump is still a high kilowatt, high amperage draw machine that is harder to run on standby power. The other planning issue that people should be aware of for a ground source heat pump is your ground heat exchanger goes outside the house, underground somewhere, whether it's horizontal or vertical. That's forever there, so you shall not build over it. You can put a driveway over it or a garden over it, but if you're planning to put an addition on your house, it's not going to go over your ground heat exchanger ever. Or if it is, you're going to have to move your ground heat exchanger. Which is why the open loop with the wells, the extraction and rejection well, has a real advantage to it. But my main bias is that if you have a certain amount of money to spend on improving the energy efficiency of the house and the greenhouse gas emissions of the house, the first dollar should be spent on improving the envelope and the lighting efficacy of the house, and that you do everything possible to plug the holes in the pail before you start pouring more water into the leaky pail. So I suspect that our surveys in the village is going to show that people have got a long way to go to tighten up and insulate their envelope, and that's where the first dollar should be spent. You want to look at a metric of what's the energy use per area of the house per year. And that's how most of the internationally recognized indicators of energy efficiency are being expressed now. How many kilowatt hours of equivalent energy per square meter per year are used by this house? And let's start talking numbers down in the 20 kilowatt hours per square meter per year rather than 200, for example. So if you've got a house that's using 100 kilowatt hours or 150 kilowatt hours a year per square meter, obviously you better take a hard look at why you're using so much before just putting a bigger engine in your car. If you're driving the big SUV and you want to reduce your footprint on the earth, yes, you can either go for a hybrid engine in the SUV, or you can look at a smaller vehicle. That's my first comment is, okay, you're looking at a different heating and air conditioning system for your house that's more energy efficient and produces fewer greenhouse gas emissions. First of all, why do you need air conditioning in Eden Mills? You want to use less, you want to spend less on heating. Have you done everything else possible? Out of this paradigm of just thinking least first cost and what is the long-term implication of it and what is the sustainability. It's complex technology. Back to what's the reliability of it. You got to prove to me, Mr. Canadian residential heating industry, that you can service this equipment. You can install it perfectly so that it runs first time when you leave my house without my having to call you back to get it working. And it's got to keep working as reliably as my other heating systems have been working. And when something breaks, I want somebody to be able to fix it immediately and without argument. And so we're still, I think, pretty early in the industry stage in that area. Insulation's just easier. I'd say the open loop is the biggest obvious environmental impact of a heat pump system. If it's simply taking water out of the ground and dumping it to the surface, I wouldn't consider that acceptable. The other possible impact is a leak of, if it's a horizontal loop, it'll definitely have an antifreeze in it, which is either propylene glycol or ethanol. And so what are the risks of a leak in that piping over the lifetime of the system? And what's the lifetime of the system? I guess we should be building for at least 50 years. So will these plastic pipe systems maintain their integrity for 50 years without a leak? And when it's time for them to be decommissioned, will they be decommissioned responsibly by pumping the heat transfer fluid out of them and disposing of that? So the question is, how does ground source heat pump heating system compare environmentally with the alternatives? And I think it's pretty easy to say that if you were to replace an electric baseboard system or an electric forced air system with an electric ground source heat pump system, you will use less electricity, and that's a overall benefit from greenhouse gas emissions, using less electricity. If you are replacing high efficiency gas furnace or gas boiler, I'm not so sure if there would be that much of a difference, but I haven't done the numbers. If you're replacing an oil furnace, definitely, you'll have much lower greenhouse gas emissions than burning oil to make heat. If you're replacing wood heat with it, I'm not so sure. It's many different ways of looking at what the greenhouse gas emissions may be with wood or other pellets or stick wood or whatever. So that's a longer answer needed on that one. If you're replacing solar, but we're not replacing solar. We're using solar as a supplement. But the alternative heating source is the internal gains and solar gains that you get in a super insulated, well-sited, passive heated house, and nothing will beat that, because those are negawatts. Those are watts that don't, or watt hours that don't have any environmental impact at all. So that's why I say again, that's where the first effort, the first investment should go, is make a better house first before worrying about big heating plant changes. It's an important potential technology in reducing greenhouse gas emissions, but it may not be number one on the list for some of us.